I am the virtual teacher at Egnatia Career College. Today we'll teach Heavy Commercial Construction, School Edition, Coordination of Drawings, Structural Drawings. This is video number 9. Heavy Commercial Construction, School Edition. Introduction. Part 4 presents a thorough examination of the information found on prints for heavy commercial construction. The materials and methods used for large buildings are different from those used in light frame construction. Also, the drawing set for a commercial project usually includes many more sheets than are found in the drawing sets for smaller buildings. To understand these drawings and make practical use of them, you need to understand the organization of the drawings and how the heavier materials are described on the drawings. Part 4 also discusses the drawings used for air conditioning and heating, plumbing, and electrical systems. For those who work in the mechanical or electrical trades, the importance of understanding the drawings for these systems is obvious. However, all the trades work in the same spaces, and the work of one trade affects the other trades. Estimators, superintendents, inspectors, and many other construction professions also require an understanding of all the construction trades. The School Edition project in your textbook packet drawings is an excellent building for inclusion in this book. It uses structural steel framing, reinforced concrete foundations, and a varied assortment of other materials typically associated with heavy construction. Unlike most large commercial buildings, however, the School Edition is small enough so that most of the drawings can be packaged with this book. Some drawings have been eliminated, either because they pertain to other work done on the existing school building or because they do not provide new opportunities for the study of commercial construction drawings. All the School Edition drawings are numbered as they were in the complete set, and the textbook makes frequent reference to the drawing numbers. The material keynotes, which are explained in this part of your textbook, are printed in Appendix A at the end. Heavy Commercial Construction. After completing this unit, you will be able to perform the following tasks. Describe the major differences between light frame construction and heavy commercial construction. Describe common structural steel shapes and their designations. Explain the differences between foundations for heavy structures and those for light frame buildings. Architectural style. Large buildings, such as the School Edition described in the drawings in your textbook packet, are usually designed in a different style from one- and two-family homes or even larger light frame buildings, such as the urban courts. Most larger commercial buildings are too large to employ the same construction methods as those used with homes, and smaller buildings and have different architectural styles than they do. For example, commercial buildings usually have a larger roof area, so it is not practical to slope the roof. This means that not only does the flat roof change the appearance of the building, but it necessitates the use of different roof framing and roof covering materials. Commercial buildings are designed to be as maintenance-free as possible. The wood or vinyl molding that decorates the exterior of many houses would require too much maintenance for a commercial office building. This is not to say that a commercial building cannot be architecturally pleasing. In fact, because more money is generally available to design and construct large commercial buildings, they often tend to be extremely attractive and viewed as works of art. However, the aesthetic qualities in a commercial building are generally built into the overall design of the building, rather than applied after the shell is erected. Larger buildings require greater strength. The weight of the materials required to build the School Edition is many times the weight of the materials to build even a large house. Also, the external loads, wind, snow, etc., on a larger building are greater than those on a smaller building. All these greater loads require stronger structural members, more precisely engineered construction methods, and fastenings that transmit the loads from one structural member to the next. This usually dictates the use of structural steel and reinforced concrete for the structural elements of the building, the frame and foundation. Structural steel. Steel is made by alloying small amounts of carbon and other elements with iron. The amount of carbon in the steel determines its toughness. Other elements, such as chromium, copper, nickel, or titanium, are used to produce specific properties. Alloying chromium with the steel, for example, makes stainless steel. Structural steel is mild steel, a small amount of carbon is used, that is rolled into specific shapes used for construction. The most common structural shapes are shown in this figure. W shapes are used for most beams and columns in steel frame buildings. The designator for a structural steel member includes a symbol or capital letter to indicate the basic shape, one or more numbers to indicate the size, and a weight per foot designation. For example, drawing S200 for the school edition shows a W6 by 25 column. This is a wide flange shape, with a 6-inch web weighing 25 pounds per foot. Structural steel members are most often joined by welding. Bolts are sometimes used to attach to similar materials, such as wood and steel framing members. Where bolts are to be used, they are usually shown by either symbols or a drawing of a bolt on the details. Detail J14 drawings for the school edition introduces often used on drawings for construction. Instead of describing all the information on the detail drawing itself, many of the drawing callouts refer to a material legend. The material legend, which is a running list on the right side of most of the school drawings, identifies all the material items in the building by a legend number. Roof edge detail J14, the drawing shown in the figure, shows 4 items identified only as 5.10D. The material legend on sheet A504 identifies these as anchor bolts. Welding symbol. Welds are depicted in drawings by the use of standard welding symbols. Each part of the welding symbol has a specific meaning. The arrow indicates what steel parts are to be welded. The term welding symbol should not be confused with weld symbol. The welding symbol is the complete symbol, including arrow, reference line, and any information added to it. The weld symbol indicates the type of weld to be made. The type of weld used most often in structural steel for construction is called a fillet weld, and is indicated by a triangle. Other types of welds include plug welds, groove welds, and butt welds. The reference line is always drawn parallel to the bottom edge of the drawing. The lower side of the reference line is called the arrow side. Any information, such as the type of weld, that is shown below the reference line applies to the side of the assembly to which the arrow points. The upper side of the reference line is called the other side. Information above the reference line applies to the side of the assembly away from the arrow. The tail of the arrow is used to specify welding processes, electrode materials, and any other specifications that cannot be shown elsewhere on the welding symbol. Shop fabrication. Many structural subassemblies are more easily or more accurately fabricated in a shop environment. For example, if a special beam is to be installed with a welded subassembly on its ends, the subassembly would probably be fabricated in the steel shop so the beam can be delivered to the site ready for erection. A large structural steel frame might require as many fabrication drawings, sometimes called shop drawings, as structural drawings. Usually the field contractors do not deal with shop drawings, and they are not covered in this book. However, it is important to recognize notes on the structural drawings that indicate a difference between field erection and shop fabrication. One example of such information is the field weld symbol. The field weld symbol is a small flag at the break in the arrow of the welding drawing. This symbol indicates the weld is to be done in the field, not in the fabrication shop. Foundations for commercial construction. Houses and small frame buildings usually have very simple foundation systems. The superstructure does not impose a heavy load on the foundation. So, a simple haunched slab or inverted T foundation is all that is required to support the building in most soil conditions. As buildings become larger and more complex, they place a greater load on the foundation system. Also, larger buildings tend to be designed with much of the load being transmitted through a relatively small number of columns, instead of being spread over a sill member by closely spaced studs. To support these loads, the foundations of heavy buildings are carefully engineered by structural engineers, and are more heavily reinforced than the foundations for smaller buildings. Generally, continuous wall foundations are similar to those for smaller buildings. They consist of a spread footing that supports a continuous concrete wall. Because of the greater size of the structure, the footing and wall may be more massive for a heavy building, and will probably require more and larger diameter reinforcing steel. The overall layout of the foundation is shown on a foundation plan. The dimensions and the reinforcement of the footings and walls are planned by engineers to carry the necessary loads. So it is likely that there will be several detailed drawings to further describe the foundation systems at different points in the building. Some of the reinforcement may be bars that protrude only a short distance out of the footing and into the wall. Reinforcing bars used in this way are called dowels and are used to keep the wall from shifting on the footing. Column footings are located by the column center lines. All these footings must be centered under the columns they support unless specifically noted otherwise. The outline of the footing is shown on the foundation plan using dashed lines. This indicates that the footing is actually hidden from view by the concrete slab. Column footing dimensions are usually shown in a schedule. There are usually several column footings of the same size. The mark schedule system allows the drafter to show all the similar footings with a single entry on the schedule. Piles are long poles or steel members that are driven into the earth to support columns or other grade beams. Pile foundations support their loads by means of several piles in a cluster, topped with a pile cap made of reinforced concrete. Pile foundations are not as common as spread footings and continuous walls. Grade beams are reinforced concrete. Coordination of drawings. After completing this unit, you will be able to perform the following tasks. Interpret the indexes and keys normally found on drawings for commercial construction. Use the number system for referencing details, sections, and other drawings. Explain the use of a grid system to locate columns and piers. Use the plans, elevations, and details to describe the layout of the rooms and spaces in a large commercial building. Indexes. A set of working drawings for a large commercial building might fill more than 100 sheets. The school edition in your textbook packet, although small by comparison with many large buildings, is part of a renovation and expansion program that spans 3 buildings and is described on 66 drawing sheets. A key plan in the lower right corners of sheets A101 and A102 shows the addition in relationship to the rest of the junior/senior high school building. Finding one's way around these 66 sheets would be a difficult task without some kind of an index. As with most commercial construction drawing sets, the cover page of the drawing set includes the index. It is not reasonable to include all 66 drawing sheets, plus the cover page, in your textbook packet because that would add the equivalent of more than 200 pages to the book. Therefore, the packet only includes the drawings that are necessary to completely understand the additions to the junior/senior high school. The index of drawings, found in this figure, lists all the original drawing numbers. The drawing numbers that are underlined indicate the drawings contained in the drawing packet. Parts of other sheets are included as illustrations in this textbook. Drawings for civil site work that are not needed for an understanding of the structure and drawings for work on other school property are not included. The drawing index includes the number of the drawing and the drawing title. Drawing numbers are made up of 1 or 2 letters and numerals. The letters indicate the basic type of construction shown on the drawing. Most architects use the letter A to indicate architectural drawings, S to indicate structural drawings, C for civil, and so on. The numbers indicate the sequence of the drawings in that section. Some architects indicate levels of drawings by using a series within a range to designate a level. For example, 100 through 199 might be reserved for foundations. 200 through 299 might be floor plans and elevations showing the overall superstructure. And 300 through 399 might be roof framing. This system is usually quite easy to spot by studying the index briefly. Material keying. In light frame construction of small buildings, it is customary for callouts on the drawings to label the material used. On larger projects, however, it is common for a material keying system to be used so that the drawings themselves are not cluttered by excessive notation. The following, which is reprinted from the cover page of the school edition drawings, explains the system. Material keying system. A keynoting system is used on the drawings for materials references and notes. Refer to the keynote legend on the drawings for the information which relates to each keynote symbol on the respective drawing. Each keynote symbol consists of a number followed by a letter suffix. The number relates to the specification section, which generally covers the item that is referenced, and the letter suffix combined with the number creates a keynote symbol which identifies the specific reference notation used on the drawing. The letter suffix does not relate to any corresponding reference letter in the specification. The organization of the keynoting system on the drawings, with the keynote reference numbers related to the specification section's numbering system, shall not control the contractor in dividing the work among subcontractors or in establishing the extent of work to be performed by any trade. As the material keying system reflects the numbering of the CSI master format, you may find it helpful to keep a bookmark in your text at this figure. The entire master format is too lengthy to include in this book, but that figure includes all of the division numbers. Figure illustrates how this keynote system works. Notice that many of the callouts on this detail are a decimal number followed by a letter. That is the keynote symbol. Referring to the index of drawings, we find that sheet A000 is Master Keynotes. The complete legend of Master Keynotes, as it appeared on sheet A000, is reprinted in Appendix A. The keynotes that pertain to a particular drawing sheet are also copied on the right end of the drawing sheet. In this figure, the keynotes on the right side of the figure pertain to the drawings that were together on sheet A302, where J14 was located. The top right callout on J14 has a keynote symbol, 3.30A. Referring to the material keying legend, 3.30A is cast-in-place concrete. This keynote replaces the customary callout on the drawing that would indicate that the landing and tread surfaces are cast-in-place concrete. More specific information, such as the grade of concrete and type of finish, would be indicated in Division 3 of the specifications. We know this because virtually all large construction projects use the CSI master format to organize the specifications, and Division 3 of the CSI format is concrete. Moving counterclockwise around the drawing, the next keynote symbol is 5.50E and is referenced to the stair stringer that is beyond the main part of the drawing. According to the material keying legend, 5.50E is covered in Division 5, Section 5.50 of the specifications, Miscellaneous Metals, and is an MC12 by 10.6 stringer. Many of the material keynotes are referenced on several of the drawing sheets. In that case, they are reproduced on each of those sheets, as well as on the master legend on sheet A000. All of the whole sheets with this book include the material keying legends. Reference symbols used on drawings. A large building such as the school addition requires a large number of sections and details to describe all aspects of the structure. The symbols for section views and the symbols for detail drawings are similar in appearance and format, but have one significant difference. While both commonly use a circle as a symbol, the circle on a plan or other large-scale drawing to indicate existing detail contains the detail number above a horizontal line. Below the horizontal line is the sheet number on which the detail appears. Some element of the symbol, such as a rectangular flag, indicates that it is a detail drawing symbol. Section view symbols use the same scheme for specifying section number and sheet number, but use a pointer instead of a rectangular flag to indicate the direction in which the section is viewed. This figure is reprinted from the cover page for the school edition. In this case, Section B2, which would be found on sheet A100, is drawn with a view of the building from the top of the page toward the bottom. The index of drawings shows that the A series of drawings includes A000 and A101 through A610, but no A100. Apparently, A100 is just a hypothetical sheet for the sake of explaining how symbols are used. An example from the drawings that are used with this textbook can be seen on the first floor plan, sheet A101. At the extreme right floor plan there is a section view symbol, with its pointers directed toward the top of the drawing. North, according to the symbol in the lower right corner of the drawing. This symbol refers to section view J14 on sheet A201. Section J14 is in the top right of sheet A201 and is a full cross-section view of the building as seen by a person standing on the building and looking north. The detail drawing symbol also can be found on the first floor plan, located just above the section view symbol at the left end of the building. The direction of the rectangular flag indicates that it is also drawn as though viewed while facing north. That detail, which is at a larger scale, 3/4 inches equal 1 foot, than the building sections, 1/8 inches equal 1 foot, is number A4 on sheet A502. Detail A4 includes further detail symbols, such as one about halfway up the wall referring to E2 on A504, an expansion joint detail, at 3 inches equal 1 foot. Interior elevations, which are often used to show the locations of fixtures, built-in furniture, and special architectural details, are usually referenced with their own type of symbols on floor plans. The symbol for an interior elevation also shows the direction from which the elevation is viewed, and it includes the number of the elevation and the sheet on which that elevation drawing appears. The symbol in this figure references elevation drawing L10, which would be found on sheet A103. The direction the triangular shape of the symbol points is the direction in which the elevation is viewed. Structural grade coordinate. Buildings with columns of reinforced concrete or structural steel as a main element of the building frame are laid out on a structural grid. The plans are drawn with a system of horizontal and vertical reference lines, so that all columns and details can be referenced to this grid. Vertical lines are numbered and horizontal lines are lettered, or the system is reversed, with horizontal lines numbered and vertical lines lettered. Columns are located by grid lines through their centers. The locations of major architectural components, such as walls, are located by dimensions that are referenced to the grid lines. The dimensions from the grid lines to the faces of exterior walls are usually given at the corners of the building. Interior partitions and other architectural elements may be located by dimensioning to the faces of these exterior walls, which are referenced to the structural grid. Mental walkthrough. As with each of the buildings discussed earlier in this textbook, one of the first steps you should take to familiarize yourself with the school edition is to take a mental walkthrough. Start at the front entrance to the first floor, in the lower right corner of the first floor plan. Enter door 101, and step into a stairwell marked stair number 1. At the far end of the stairwell is door 102, which opens into a corridor. If you turn right in the corridor, you can walk up a ramp into the existing building, 10 inches higher than the first floor of the addition. Across the main corridor of the addition are the doors into 2 toilet rooms. A symbol in front of those doors indicates that elevation A8 on A610 will show you what the toilet room doors look like. As you continue your walkthrough, you will come to many more elevation symbols. Look at each of the elevations on your walkthrough to help you form a mental picture of the addition. You will also see several detail and section symbols. It will not be necessary to check each of these to form a mental picture of the addition. But you should look up a couple of each, just to make sure you are comfortable locating them. Moving to the west in the main corridor, you come to a door, 103, on your left. This is the entrance to a storage room. A dimension inside the storage room indicates that it is 13 feet 8/2 inches wide. The exterior wall, south wall, of the storage room is on grid line F, see the left end of the floor plan. The wall with the door is on grid line D, which is 32 feet 7/2 inches from grid line F. You could determine the actual face-to-face dimension between the north and south walls by looking at the details and sections. But that is not necessary for this mental picture of the building. Notice that where the east and west walls of the storage room intersect with the wall of the corridor, there are 2 heavy dashed crosses, indicating columns. Most walls are on column lines. These are on vertical grid lines 6 and 7. Now walk through the janitor closet, JAN. CL, each of the classrooms and all corridors and stairwells. Only a few highlights are described in this textbook, but after you have followed the walkthrough described here, you should take a second walkthrough, noticing and studying everything until you can visualize it. Along both sides of the corridor are several references to Material Keynote 10.50a. Find that keynote on the legend at the right end of the drawing sheet or on the Master Keynote legend. Through door 105 you enter classroom 103. On the floor plan, room 103 is only separated from room 104 by a single dashed line. That warrants investigation. A detail symbol directs you to A6 on sheet A504. That is a large-scale section view of a track detail. Looking again at the floor plan, you see a material keynote reference near the lower end of the dashed line, 10.62a. According to the legend, 10.62a is a folding partition, so rooms 103 and 104 are separated by a folding partition. Across the corridor from classroom 103 is stair number 2, which goes to the second floor. At the extreme left end of the corridor is a large rectangular area identified by keynote 14.20a, an elevator. Take the elevator to the second floor. When you step off the elevator, you are on the second floor. Your walkthrough is continued on sheet A102, second floor plan. The second floor of the addition is almost identical to the first floor. It would be foolhardy to take for granted that the two levels are identical, but a quick survey shows that they have the same rooms in approximately the same layout. The rooms on the second floor are numbered in the 200 series to indicate that they are on the second floor. Structural drawings. After completing this unit, you will be able to perform the following tasks. Describe the footings for columns and walls, including dimensions and reinforcement. Interpret the information found on a foundation plan, including dimensions of foundation walls, reinforcement of foundations, and the locations of the various elements. Describe each column, beam, and lintel shown on the structural drawings. Interpret structural details and sections. Foundations for commercial buildings. The foundations for large, commercial buildings perform the same functions as those for light frame buildings. The foundation supports the loads, weight, imposed on the superstructure and spreads those loads over a large enough area so that the earth can support it uniformly. In most commercial construction, the foundation system is composed of spread footings and stem walls and pads that act as footings under columns. These are the same elements that are found in most one- and two-family homes. The biggest difference in the foundation for a commercial building, and that for a small house, is the thickness of the concrete and the amount of reinforcing steel. There are apt to be more detailed drawings for the foundation of a larger building because of the need to describe the different sizes and shapes of footings and the reinforcement at many points in the foundation. The same knowledge is required to read the foundation plan for a large building as for a smaller one. The drawings consist of a plan that shows the layout of the foundation and the major dimensions and detailed drawings that describe reinforcement, expansion joints, and variations in design at special locations. The placement of column footings is indicated by referencing the structural grid coordinates. The structural grid indicates where the center line of the column will be, but it is very important that the footing be placed accurately on the center. If the column does not rest on the center of the footing may tip due to the uneven pressure on the soil below. Structural steel framing. A structural steel building frame consists of columns, vertical members, and beams, horizontal members. The largest beams, called girders, attach to the columns. Joists are intermediate beams and are supported at their ends by the girders. Lintels are the beams that support the weight above an opening, such as a door, window, or non-structural panel. If the first floor is a concrete slab, it is described on the foundation plans and details. The second and higher floors are described on framing plans, as is the roof frame. Many buildings have several floors that are framed alike. In this case, a note might indicate that a framing plan is typical. Framing plans for structural steel are drawn on the structural grid coordinate system. Beams are shown by a single line symbol with an accompanying note to indicate the structural shape to be used. The lines indicating beams stop short of the symbol for the girder or column when the beam is framed into the supporting member and does not continue over it. The abbreviation DO, which stands for ditto, indicates that the specification for the first member in a series is to be repeated for all members. A number in parentheses at the end of the designation is used to indicate the elevation of the top of the member. This may be the elevation or the distance above or below the floor line. Joists are frequently open web steel joists, sometimes called bar joists. Bar joists are manufactured in H, J, and K series, depending on the grade of steel used and their strength requirements. K series are stronger than H series, and H series are stronger than J series. A bar joist designation includes a number to indicate depth, a letter to indicate strength series, and a number to indicate cord size. For example, the designation 16H6 indicates a 16-inch deep H series joist with number 6 cords. The actual lengths of members are not shown on the general contract drawings. This information is shown on shop drawings that are drawn by the steel fabricator some time after the construction drawings are completed. It is an easy matter, however, to find the span of the member by looking at the framing plan. Connections are shown on details and sections. Lintels are sometimes categorized as loose steel. In masonry construction, a steel lintel is placed above each opening to support the weight of the masonry above the opening. These lintels are not attached to the steel building frame, which is why they are called loose steel. If there are several lintels alike, they are normally shown on the plans by a symbol, and are then described more fully in a lintel schedule. Masonry reinforcement. Masonry materials have great compressive strength. That is, they resist crushing quite well, but they do not have good tensile strength. The mortar in masonry joints is especially poor at resisting the forces that tend to pull it apart, such as a force against the side of a wall or a tendency for the wall to topple. Masonry joint reinforcement is done by embedding specially made welded wire reinforcement in the joints. Greater strength can be achieved by building the masonry wall with reinforcement bars in the cores of the masonry units, then filling those cores with concrete. Concrete used for this purpose is called grout. Reinforcing steel is also embedded in masonry walls to tie structural elements together. For example, it is quite common for rebars to protrude out of the foundation and into the exterior masonry walls. The strength of a masonry wall can be increased considerably by the use of bond beams. A bond beam is made by placing a course of U-shaped masonry units at the top of the wall. Reinforcing steel is placed in the channel formed by the U-shape. Then the channel is filled with grout. The result is a reinforced beam at the top of the wall.